Good afternoon, everyone. How is everyone doing today? Can you hear me fine? Is everyone doing fine? Let me know in the chat if you could hear us. Let me welcome James also. Hey, James, how are you doing?
Good morning, Ashish. I am doing well today. How are you?
I am okay. I'm okay. Excited for another session. We have a
Yeah.
guest speaker also lined up. We will talk about that. But yes, always happy to share knowledge. Also happy to see people getting motivated. And we keep on hearing good news that people are progressing through their interviews. We have a couple of candidates who are into the second round or into the loop round. So hopefully we would have more people onboarding AWS and helping us to reach out to more customers. So let's see how it goes. And everyone feel free to share if you have any feedback, anything which we could help you with, just feel free. We may try to respond to each of you, but sometimes if we forgot, just give us another nudge and we would be happy to take it forward. And we are happy to refer you internally if you want, but don't like send us 10, 15 list of jobs. This quality is that important over quantity. So look for what aligns most to you. And maybe not today it is aligned, but maybe later it would be aligned. But check what is your motivation, what keeps you motivated, and what you want to be. And we would be happy to have a chat and help you with your career goals if we could. So thank you, everyone. Let's get started with this session. I'll quickly talk about what this agenda is, and then I'll talk about the how we will be progressing here. So for this particular session, we will be talking about KMS, which is our security service, which is encryption services. So I'll talk about that. Then I'll let James talk about serverless in a serverful world, because lots of time we have servers and serverless communicating, and how that pattern may look like, or what kind of communication patterns would be required. So we will be seeing that. And then we have a guest speaker who is coming from Canada, means obviously online, and she would help us in understanding how was her journey and what keeps her motivated. She is a very prominent speaker for inclusion and diversity. So she would be talking about that, and it would be a good power pack 15-20 minutes of the session. So thanks everyone for being here. Let's get started. I'll let you focus on the content, and we will discuss more interesting stuff. And if you have anything, feel free to put them into chat. We are looking to the chat, and we would try to respond to as many questions as we can. Okay. All right. Question. What you see here is there something, is a picture looks little interesting one. Anyone, any idea what this picture is representing? What is being represented here? Any random guess? It is not a friendship band, I can tell you that. What else it is? What you think it is? And let's talk about it. Yes, I'm getting a lot of people talking about encryption. Yeah, why not? What else? Any other thoughts? What you're saying here? It is a key. It's a suitcase lock. It's a message exactly. A typical lock key. It's a key. It's a puzzle. In a way, encryption, if you look at it, isn't it a puzzle? Isn't it? So it is a encrypted message. This device, what, it's not that sophisticated, but this is called Cytel, and this was used by ancient Greek lords who would be sending messages, the military messages, in a encoded format into cryptography. So this is a leather strip. They would have their message written on it, and if you see the wooden piece there, that wooden piece have different shapes or size, and based on that, only that wooden piece, the matching wooden piece, would be able to decrypt it. Not very sophisticated, but still it is a very early form of how encryption used to be. And obviously we have come a long way from there. Look for this information. This is called Cytel, and you could get this data into Wikipedia. I have taken the image from there, but it was a very early way. The ancient Greeks and Spartans in particular are said to have used the cipher to communicate during military campaigns. So even if physically somebody gets hold of it, unless they have the right key, they would not be able to get that information out. So that's how the information was shared. So that is called my title. All right, good. Let's move forward and let's discuss the details now, that what we are going to discuss into this particular session. So idea here is that we want to discuss about that how exactly this encryption works. We talk about encryption in two terms. Interesting trivia, exactly. So we talk about two terms in encryption. Now it is, I am representing in terms of AWS, but even in on-prem world, it remains the same. That's how all these things work. So this is the entry point for any application. Then entry point may be talking to a front end or a processing application, and then it would be a storage by which your data would be accessed or retrieved. If I'm talking about AWS entry point, most of the time you would have load balancers, API gateway, or CloudFront as your entry point, and then you would have your front ends running maybe on EC2, maybe container, maybe Lambda. It depends on how you want to configure. And at the back, there would be storage on which you would be keeping your data. Your users would be accessing your entry point first, and then there we have to ensure that we provide encryption in transit. Means whatever my user is sending, I want that data to get encrypted, and over the wire it should be forwarded into encrypted format. So even somebody sneezes in or snoozes in inside, they wouldn't be able to get the data from that. So encryption in transit is what we do. Encryption in transit is implemented by SSL or TLS certification. SSL stands for Secure Socket Layer. TLS is Transport Layer Security, and their job is basically to encrypt the data which is being transported over the wire from point A to point B, and they work with public-private key mechanism to get the thing started. And then AWS has a service called AWS Certificate Manager to help you achieve this. Through this service, you could generate SSL TLS certificate and can associate it with your application front end. That's not at all a problem. So that's what is a standard way of providing encryption at the transport layer. What my focus is today is at encryption at rest. Encryption at rest basically says that, hey, you stored your data. What if that hard disk gets compromised? Somebody steals that hard disk, though very rare, and then takes it to their home, connects it to their computer. Can they decrypt that data? So that is called encryption at rest. So once my data has been stored into a storage service, I want it to remain encrypted. And for that, we would be leveraging AWS KMS service, which is called Key Management Service. And through this, we can generate encryption keys, and those keys can be used to protect my data. So we will be discussing and focusing today on KMS, Key Management Service. Let's get started here. Okay. So we have key management service, which is called KMS. And obviously, as I prefer to explain things through analogies, I would again prefer to explain these keys and concept related to your security and encryption through an example. Now, James, I have taken your name here. It is a screenshot. There's a picture I could get from somewhere called Bank of the James. So let's consider that there is a debit credit card which you have. Now, debit credit card is basically a way by which you are able to access your money or perform some transaction. And to withdraw money, you have to take it to an ATM, and then you have to provide a PIN number. Now, PIN number is basically what would be the way to get into your account. That is your password, that is your secret, that is your key, which allows you to open your bank account and withdraw money from that. So that's all we are utilizing here. That is called 4582. That is my PIN number. Now, I recently completed one implementation of CF and ACM. That's a good thing, Asna. So feel free to share that once you have a blog. I know you write blogs, so feel free to share that with everyone. All right. So this pin is allowing me to go into the things. Now, I am not a person who is good with numbers in terms of remembering them. So if I say that, hey, I want a way to keep my data safe, or I want to remember these numbers, one option for me is I could write down this number 4582 on the card itself, because it is the best way, is basically most convenient way to keep that data 4582 written on the card itself. But that is not at all a secure thing, because if somebody is now able to get my physical card, they would know the PIN number also, and that is a security risk which I don't want to take. So what I do here, I implement a solution. It is not exactly encryption, but it is a similar way encryption works. I say I want to store 4582 in its format, but I don't want to save it directly. Let me use a mechanism of adding +1 into the first digit and -1 into the second digit, and then store that number. So what I do here, I take this 4582, which is my plain text data. I apply my encryption logic, which is my +1 and -1. On first digit, I would do +1, second digit -1, third digit +1, fourth digit -1. Very basic, not a very highly sophisticated formula. But what I get from that 5491, This number is what I could safely write on my debit credit card, and if somebody founds it, they would still not be able to figure out what this 5491 is. If they try to access my card using this, then it would fail, it won't allow it to it. So what we generated here, 5491, from a plain text, that is called a cipher text or encrypted text. Now, it is not exactly encryption, it is obfuscation or replacement of the digits, but it is in a way an example of what a encryption may look like. Is everyone following along? So what we are doing here, we are utilizing some key. That key here is my +1 and -1, and through which I am able to store my data. And then once this data is there, if I have to use my card, obviously ciphertext cannot be directly used. So what I have to do here, I have to decrypt it, and that decryption would say 5491. Let's take that. Then we would go ahead and say -1 +1 -1 +1. Basically, in a simple math term, I reverse the key. And once I have reversed the key, what I would be getting would be the actual number, which is my PIN. And that's how we would be able to access the card. So I could still safely write 5491 on the card, but only in my head I remember that what was the key actually used. I have not stored key with the card itself. I have stored the PIN in an encrypted format into the card, and then I use a key to get that decryption done, and through that I can now remember my numbers. Isn't it easy? Like, I'm not good at numbers, so I follow this. Obviously I don't use always +1 -1, so don't worry on that. So what the example tells me, that the key I am using is a +1 and a -1, and any encryption key is made up of two things. There is a algorithm. My case, the algorithm is plus a digit and a minus a digit. That is my algorithm. And in that algorithm, I feed a value. That value I feed is one, that is called key material. So these are the very common terms which people will find when they talk about encryption, that which algorithm you are utilizing, AES 256, SHA-25. So that's how you would be able to utilize this thing, which is your algorithm. And then value is what I have provided here as +1, as a one, and you could have selected second or third. Now, I will probably not prefer to keep all my card keys into the same +1 -1 format. What I may do, let me check my credit card number or debit card number, and let me take the second digit of that card and use that as a key. So if this card has the last second digit as 3, then my formula will be +1 -3. I have another card which says 2013. In that time, I would have used +1 and -1 as my key. So what I'm doing here, I'm not relying on the same key every time. I am rotating the key with a different mechanism. I am still keeping the same algorithm, but the value I am providing in that is changing depending on which specific card I am going to utilize. So hopefully this gives you an idea that what is encryption and how there could be. So there can be more than one key material, right? Yes, obviously it would be. So I would still keep same algorithm, but in that algorithm, let's say when I say I am using AES 256 as algorithm. Now everyone uses the same AES 256. So what makes it unique is the value which you provide, which is your key material, that makes that encryption mechanism unique. So I use plus and a minus as my algorithm, and I may have used one, and you may have used eight, another one may have used three, another one must have used -3 on that. So that is what makes my values unique, right? So hopefully this thing is clear. Okay, good. Let's move forward. So the service we offer here for that is called KMS, Key Management Service, AWS KMS. It helps you to create, control the keys to encrypt or digitally sign your data. There are multiple usage of the key. We will focus on some of them. So it's a fully managed service. It has built-in auditing, so we would know who used actually. Then we would have compliant with PCI, HIPAA, and other services, and it support custom key store also, so you could bring your keys also. Now what KMS is, to understand KMS you have to think about one typical device, which device is called HSM. Let me show that HSM device. What is HSM? HSM stand for hardware security module, and this is basically a physical device on which keys can be stored safely. Now, in some hardware, it would be something which is a card attached within your server, or it could be a dedicated server like this. So if you see this thing here, this is a company who manages and create these type of hardwares, HSM. These are tamper-proof devices on which keys can be stored. So HSM is a common term which stands for hardware security module, and that security module is basically a physical device which is designed to keep your keys safe, tamper proof. It has its hardened operating system, it has a security mechanism. So HSM is a device on which all these services are maintained. Now, if you prefer that, hey, I would maintain and create or use or create or maintain my own HSM devices. So no problem, go to a vendor, get the hardware. Then it is one hardware only. What if it fails? So probably you would have two of them. Then then you may have then requirement to add more. So you keep on adding those hardware and you maintain it on your own. You have to take care of its availability, performance, security, and that can be costly affair for a lot of businesses. So what AWS says, hey, let us help you there. What we would do, what is AWS approach? AWS would create a cluster of these HSM devices for you. Let me draw that again. So in AWS, all these HSM devices have been already provisioned, and then you just consume or store your keys on that. So we have cluster of these HSM devices which are being maintained, secure, updated by us, and you as a user are allowed to store your keys there. And how much you pay in that case? You pay for the per key you store, and that is what the way of KMS service is. And the KMS is the service which allows you to access these hardware modules. You don't see hardware module, for you it becomes a service. So you say to service, I want to create a key, or I want to have a decryption done, I want to do encryption, and you make a API call to KMS service. At the backend, KMS may be leveraging some hardware devices to safely store your key, and there could be multiple devices which are created and run as a cluster, so that even if one of them fails, you would still be able to recover it. So that is what KMS is doing, and it has additional thing that it gives you policies to control who can access key or who cannot. Are we clear on this so far? Any questions, any doubts, any confusions on that? All right, so hopefully this thing is clear. And let's see now that let's go to KMS and let's perform some operations there. So I'll try to log into my console of Amazon, and then where we will be performing some KMS related operation. What we will do, we will create a key and we will see that what are the different options available for me inside KMS. All right, so we will see this thing, how this actually works. So these devices are multi-tenant, or every account has dedicated cluster of KMS behind the scene. These are multi-tenant by default, but there is an option where you could say, hey, my compliance requirement wants me to have a dedicated single tenant device. So we offer you that also. We will talk about that also. That service is called Cloud HSM, but yes, that option is also possible in case you need that. Right. So in a customer implementation, either HSM or KMS, so a customer can have both. It is your decision, right? You decide. Maybe some data you want to have decrypted and encrypted locally. You don't want it to go at all, any keys to be outside world, then you would have your own HSM. Or you could create keys in your own HSM and then import it into AWS KMS for wider usage. So that is also possible. Both type of scenarios are available, and it is very flexible way to get started. Should not be a problem at all. Okay, so it is up to you. So what I'm doing here, I am going to Ireland. Just to start with the example, I would go ahead and I would go ahead into service called KMS, and my intention is first right now to create a key, and that key further I could use with other services which are integrated with KMS. If you see here, there are a lot of keys which I have already created: Atlassian key, encryption sensitive data, SENG key, financial data key. So these are the keys which I have created. See, three options. First one is customer managed key. That is where I came directly. That is what my keys are, which I created for my usage. Then there is AWS managed keys. These are the keys which AWS has created on my behalf. If I have used services like if I use DAX, RDS, FSX, and if I use encryption feature of those devices or those services, that is where this option is automatically selected for me. AWS has managed those keys for me. Right now my interest is on a customer managed key. AWS managed key, you can't do anything on that. See this, you can't go ahead and say, hey, I want to delete it. You would still be able to see what it is, but you can't delete or modify them. But here I am interested into creating my own key, and see this, enable, disable, delete, cancel, delete key material, edit or tags, all these things are there. We could utilize that, right? So even S3, I don't understand what does man. Yes, S3 is also integrated. Yes, S3 has a default encryption. So if you are using default encryption of S3, that key was displayed there. Yeah. We can have on-premise HSM where the cloud service connect to. Yes, why not? See, it is a service, we know, right? So you say, hey, I want to keep my service into cloud, but its encryption key for compliance reasons should be stored on premises. So your cloud service can make a API call to your on-prem infrastructure, provided you have network connectivity to your public endpoint, and get your key from there. Should not be a problem at all. So yes, any combination is possible. Right. So we have symmetric and asymmetric two type of keys. Symmetric is same key used for encryption and same key used for decryption. That is your symmetric key. Asymmetric, it is a key pair, one for encryption, one for decryption. So whenever I am SSL certification is used, that time asymmetric keys are used. In encryption, mostly symmetric keys are used. So I am using here symmetric key, and I am asking what is the usage. I say I want to use it for encryption and decryption. That's fine. Let me get started. Let me call this BeSA demo key. Done. I could give some description. I could add some tags to identify that and add permission and all. Now this is very important aspect. There are two type of personas which can be there with your keys. What are two personas? Two personas. One is a key administrator who is admin of the key, and second one here is a key user who would be entitled to use that key for encryption or decryption. And we keep separation of role to ensure security breach doesn't happen. So even if you are admin, so you would have permission to enable, delete, update, revoke, or all these things. But that doesn't mean that you could enable encrypt and decrypt also. Encrypt, decrypt would be a responsibility of a user, and by default it would be only a user who would be able to perform encryption and decryption. So we keep separation of duties here and ensure that only the required people have administrative access, and required people can only access your key. So what I'm doing here intentionally, I am saying my key administrator is admin underscore ash. So I'm making admin underscore ash as my administrator of the key. Then once this is done, then we are utilizing key deletion facilities also. Then again we go forward with that, and here I define that who is going to be my key usage, right? So what is my key usage permission? So I say, hey, this user permission I am going to give it to user number D1 and D2 only. These only two users are allowed. Obviously it could be a role, it could be group, or it could be other AWS account also. It depends on that. Santosh has a question: what is the difference between KMS key and the key which is used to access EC2? See, similarity is first is both are keys. That key which you use in EC2 access, that is a asymmetric key. There is a public part and there is a private part. Public part remains with the instance itself, and it's a private portion is given to you when you say download the key. So it works with a combination. It's like a combination lock. Two people have to put the right key, then only it works. So KMS key are both symmetric, asymmetric, but EC2 key is a asymmetric key. It may still be stored or utilized using here, should not be a problem, right? So I selected two users, and let's see what happens behind the scene. What my KMS service is doing, KMS service is creating a policy with the key that is ensuring that only the required people can have access to the key. Not everyone can have access to the key. So see this. So first thing here, I am user permission being allocated. I am making a user who is called admin underscore ash key administrator, and that person can perform all these operations. And then I have two users, D1 and D2. To them I am making key user, and what they could do, they could do encrypt, they could do decrypt, and they could do re-encrypt plus generate data key, which is very important aspect. We'll discuss that, and they could describe key. So that's how we have created a key, and with that key we have associated who is allowed to access this particular key. Every key has a policy which makes sure that only required people can have access to it, not everyone can have access to it. So that is what we would do, and I say now finish. Done. So I have my key created, and that key is available, which I can start using in other services if I want to, right? Cassandra is used internally. As James said, no, we do not know. And even if the service team knows, they won't be saying that. And actually, it doesn't matter what is being used because it is a service, right? So if you go to McDonald's, you want a burger, you don't worry about like, hey, are they using air fryers? Are they being paid hourly or weekly? Are they full-time employee or part-time? I don't care. It's a service I need, and that's all I worry about. That's all I need. Right. So my service is ready, and service has created a BeSA demo key, and I could then start utilizing it into any compatible services. So let's say I am now looking to use this key for encryption. I am going to an S3 bucket, and in that S3 bucket, I could say, hey bucket, I want you to encrypt everything which comes into you. And for that, I want to use a specific key if I want to. So I could go ahead and select any of the buckets and start using it for the security of it. So I could go ahead into properties, and I should be having either default encryption, or I say no, it doesn't work for me, I want to have a server side encryption. I would use the key which is created in KMS, and I should be able to choose my KMS keys which are there. If you see this is my demo key BeSA, and now everything coming into this bucket would be encrypted by the key I selected, not the default key. So that's how this KMS service integrates with different services also, and you are able to get all these data sorted from there. All right. When we use customer managed key, where the key will be saved, customer managed key, there are difference there. Customer managed key is again, let's say what I created here, what I have here, this is still my customer managed key, isn't it? It is still being stored into a KMS service, the hardware devices which I talked about, it is being stored there, but the ownership is with you. So it is still in a multi-tenant physical hardware, your data is being utilized. What about the existing object? You have to run some job to encrypt it, because see, a policy is applied encryption would be applied once you create a policy, right? So if I say that taxation, or let's say income tax, is going to be reduced by 5%, that means from today or the date I announce, from then it is going to be reduced, not that I am going to get paid for the previous thing. So whatever you apply, it takes into effect that very moment, and anything which comes afterward, not before it. So if it is before, then you have to do encryption there. Is everything in that bucket automatically encrypted, or does it apply just for a few objects? By default, if you see, remember, I selected that as a bucket key. So that is a bucket. Everything in that bucket would be encrypted by this key. So that is a bucket key, and it applies on a bucket level, which would include every object within it. But if you feel to have an object level key, nobody is stopping you. You could do that. The key has been tied down to the user, but say if connect to an S3 and access publicly, then can it be encrypted for all? No, KMS keys can't be. KMS keys have a policy, Parna. So if you remember that we set a policy, and in that policy we said who has access and who doesn't have access. So in this list, I have only D1 and D2 who could decrypt it. Even if I make this bucket public, people would not be able to get the content of them because that is encrypted. So that won't be visible to them even if you make this S3 public, because there is one more layer of security which we have just added. Are we clear on this so far? Okay, let me show you a quick demo so that you could relate to what I have just discussed about. So give me a minute. Let me get that demo sorted for you. Yeah, KMS demo. This is implemented in JavaScript. What I'm having here, I am making those API call to the service. So what API calls are, see this. First API call I could make is maybe describe keys. I want to know what keys are available. So this is what my list key operation is. I say I want to list the keys. So it has displayed to me. I have already have the JavaScript and the encryption in the credential already on the page. So it says that these are the all available keys available to me. right? So this is what we have, and this is all the list keys which I have done. Now here I could try using a KMS key to encrypt the data. KMS key to use, let me explain what is the KMS key I want to use in this case. So I could say, hey, I want to use this key which is created by me. Let's say that key is your security engineering key. This is my key ID, key ARN as we call it, Amazon resource name. And I say, please use this key and go ahead and encrypt the data 1234. And I say encrypt. I get a message that, hey, you are not authorized to use the key. So you have list permission on the key, but you are not authorized to perform encryption operation. For this particular demo, I have actually given permission only to one key, which is my encrypt sensitive data. Let's use that key and see what is can be done with that. So I say use this key and do encryption. Basically what I'm doing, I am making a call to KMS and say, KMS, encrypt this data. This is the payload, and see what happened. Now it is not like 1234 convert to ABCD. It is a big number which is being converted into. So this is my converted data, which is representing 1234, which I have just seen here. All right. Okay. Now question to you. Pay attention what I'm saying. If I invoke the same operation with the same key and same data, will the encrypted data remain same or will it change? Right? So I'm saying I still use the same key, I still use the same data, and will the encrypted data be changed or not? It will change. Yes, you are right. Let me show that. So I encrypt it again, encrypt it again, encrypt it again, encrypt it again every time the data is changing, but some data is not changing. Let me show that to you. Now I'm putting this information here. Let me again run encryption again. See this all encryption. I again run some encryption and see this what happened. These are the data which is being created, right? Now it will change, always change, but let's see. If you look at this till this point, which is 0, 1 up to this point, do you see any change? Do you see this whole string up to 0, 1 is same, up to 0, 1 this is same, up to 0, 1 this is same. Obviously the later part is changing. What does it mean? First line is not changing. Yeah, that's not changing. Why it is not changing? That's the question. That's the question, why it is not changing. A header you could call it, but we call it another word called metadata. Not key material. Key material can't be exposed, then otherwise everyone would be assaulting. Kind of, we call it metadata information because that says that it is which key was used for it. So it is a metadata information. So if I get this encrypted information now, if I have to decrypt, I don't have to say which key to decrypt it. Like on the lock, key number is mentioned that this lock can be opened by key number 15, 30, 400, whatever the number is. So when I say I want to encrypt, I want to decrypt the data. I take this data and say, let me decrypt. And what I get is the data. And it also tells me which key was used. So this information or which key to use is stored with the key. That is called my metadata information. So metadata is stored with the key. So every time I do encryption, I would get a different object, and every time I do decryption, I would get the same result, and that would be not do not have to specify which key to use. It would know which key to use for that, and that's how it will be work. Right. So hopefully this thing is clear. So what we could do with this, we could utilize KMS and perform lots of operation. Let me go back to the slides. I'll talk more in that. So KMS provides you two-tier architecture of using envelope encryption. So envelope encryption, I'll explain. KMS keys, what we saw just, but those keys can be used to generate something called a data key. I'll talk about envelope encryption in a minute. And as a user D1 and D2, not D1 and D2, I haven't used that key Parna. It is a completely different user. I'm using a KMS user here for demo purpose, but that's all. Encrypted data hold the info, but key as well, not the key, the name of the key or detailed number of the key that it holds that, not the key itself, not the key. So data key encrypts customer data. Let's pay attention. We have limited time. So KMS is service which generates key. With keys, I can have policy. And with these keys, I could do what? I could generate something called data key, and actually data keys are used for encryption. If you see this thing here, that KMS generate data keys operation through which I would be creating a key. Why? Because the limit of a KMS object is, or a KMS key is, that it can have a data up to 4 KB only encrypted, not beyond it. So obviously my objects would be higher, S3 bucket would have a lot of data, and that's why 4 KB may not work. So what we do, we perform a one more layer of encryption, which is called generate data key, or that is called envelope encryption. Let me go ahead and give you an example of what envelope encryption is. Again, analogy to give you an idea how envelope encryption actually works. So this is a house key. I'll give you my example. I'm single parent from long time. So my son would go to school and then I have to give him key because I may be in office, and that would be a little complicated because being a boy, he would have lost the key and he has to wait, or I have to rush from office to get him in. So that was complicated. So we started storing key here. Is it safe? Obviously not. It is not a safe thing. If I keep it below doormat, we most of us do sometimes, anybody could get that, and that is not at all a good thing. So we want to do one thing. We started thinking about a key safe. What this key safe is, this is a device like this, and this kind of a device you could put it on your home, and what happens now that there is a number on it, and then there is a key which you could store inside it. So this is envelope encryption. What is happening here? My house is what I want to protect. To protect the house, I have a house key, and this house key itself need protection. So what we do in that case, this house key, I would put it into this device, and I have used one more key on top, and that key is protecting the key itself. You get the idea? So that is an envelope put on the key itself. That is a key which is the most important thing to protect. I use one more key on top of it to perform encryption. That is called my generate data key. So what we do, we say KMS, this is my S3 object. I have to upgrade, I have to encrypt it. S3 would make a call to KMS service and say, KMS, give me a data key. And that data key is actually used to perform encryption. And that is how your envelope encryption actually works. So what actually we do, when we say generate data key, KMS service would deliver me a data key, and that is basically a randomness, and through this randomness we are utilizing other services, right? So let me show that. So KMS key to use, I say, hey, I want to use the same KMS key, which is this one. I'm showing a demo of generate data key now. So I say, hey, I want to utilize this key usage here. And I say, I want to invoke a call which is called generate data key. I'm not encrypting, I'm not decrypting. I am issuing a call which says generate data key. So what KMS service did, KMS service has created a random number for me. Let me refresh this thing again. Let me type this. By mistake, I clicked refresh. So when I say generate data key, I got a data key which is a random number, and it would change every time I issue the request. See this generate data key, every time this number is changing, and that is ensuring that I am getting unique random numbers created for me, and that is what I would actually be utilizing for my application, right? So that is how we should be able to create a data key, and that data key would be actually used for your encryption. Now one more thing, one more question here. Let's say this is my S3 bucket. On this S3 bucket, I have say, hey S3, you have to use a key, and let me call it that key one, right? I have 10 objects here in this bucket which are encrypted with this key. My question to you is, will it be having 10 data keys, or will all the object would have one data key? That's my question. I have selected a key at the bucket level. The bucket has 10 objects in that. So my question is, will there be 10 data key generated, or will be one data key which would be protecting all 10 object, or will every object have its unique data key? What do you think would be happening here in this case? Any guess? Anyone? Any solution you could think of what would be happening? Would it be 10 data keys, or would it be one data key? All right, hopefully everyone is following along. One answer is wrong. 10. See, when you say, hey, I have an object to store, Go to S3, sorry, go to KMS. KMS give me a key, KMS will give me a random number. I would use that random number to store with that object. A second object comes in, I would again say KMS give me a key. KMS will again give me a random number. So with every object, there would be multiple, there would be different keys which will be created. So data key would be unique to every object. The plain primary key which is used, that would remain same. So it applies on whole bucket, but the data key is generated for every object you store. Even if it is a database, every table if you encrypt may have a different key, so it depends how you configure it. But in KMS that would be all these S3 bucket would may have the same key, but the data key which is generated would always be different. Are we clear on this? So hopefully this one is clear. Now I have limited time, but what I'm going to do, I would share this presentation on the resources page, and where you would be able to see how all these things work. So what I have done, I have put animation here, and that is available, will be made available on that. So you should be able to access these services and see how encryption works, how decryption works, and what is the total way of doing encryption and decryption cycle. So hopefully this is how things would be there. All right. So hope you enjoyed, hope you learned something new on the KMS side and understood some of the topics. Question here is, but the all the house, do you have the same key? Yes, you see, this was example, Revati. Why not? See, in that example which I have shown, maybe I have multiple keys. In your house, there would be entrance key. Do you use the same key for your cupboard also? For your locker also? Obviously not, right? But the key safe remains the same. Maybe in this key safe I can keep my house key, my car key, my locker key, whatever. That's not a problem. So that's how it would be different on that, right? So that's how we would be working. So I will share this presentation with you, and you would have access to this content. So hopefully you would enjoy and have learned. Will the AWS changes for every charge for data key? uh, there is different charges. It is a little longer discussion, Santosh, so we have to park it, but check on pricing. You are charged for the API request you pay, you use for the master key, primary key, and you are charged for number of keys you create. So that is what you would be utilizing. You would first have a number of keys, that is what you pay, and how many time you say give me data key, generate data key, encrypt, decrypt, that would be all the things which will be there, right? So let's take a short break. Once we return, then James would talk about all the stuff. So James would be helping us today with serverless and all. But keep your questions coming. Send it to me on LinkedIn if you want to reach out to us, and we would be happy to help. And hopefully everyone has a good idea on how encryption actually works. Okay. All right, so enjoy your break. Talk to you in 5 minutes. We would be utilizing these things. So we'll see all these stuff into 5 minutes. Okay, so enjoy your break. Talk to you in five. Thank you. Welcome back, everyone. Let me make James presenter and add him to the stream.
Thank you, Ashish. Can everybody hear me okay? Awesome. Let's get my screen on and let's get started. Okay, awesome. So this week, let's just hide that because I always forget. There we are. So this week, as part of the serverless specialist track, I actually wanted to talk about how serverless applies in a world where maybe you have some parts of your system that aren't serverless. And the reason I want to do that is, unless I love serverless. Serverless is my favorite way of building applications. But unless you're working maybe for a brand new company or you're building a brand new system or a startup, the chances of getting an organization or a system that is already completely serverless is pretty unlikely. Any organization that's been around more than the last few years where serverless has really taken off, they probably still have parts of their system that are running on servers or maybe databases. Maybe there's still some work on premise. Adam Selipsky, the CEO of AWS, did an interview with CNBC earlier this year. And in that interview, he was talking about how much of customers' workloads are still actually not even in the cloud. And his estimation was that only 10% of IT workloads have actually moved to the cloud. Now, of course, these numbers are an estimate, but that's 90% of IT workloads that are still in data centers, still on premises, that even need to get to the cloud. And even once these workloads make it to the cloud, in most cases, these are likely to be lift and shift migrations, where they're just taking that infrastructure on premise and moving that and running that maybe on EC2 instances or RDS databases on the cloud. So these still aren't serverless workloads. These are still server full workloads that we need to communicate with in some way or work with. So let's consider a typical 3-tier application architecture. And let's say we've picked this up from our data center and we've moved it into the cloud. So this is a public facing API. We have some kind of load balancer in front of some EC2 instances. And our application runs on these EC2 instances and communicates with a database running on RDS. And this entire application sits within a VPC on AWS. Both the EC2 instances and the RDS instances are deployed into private subnets in that VPC, meaning they can't be accessed by anything outside of the VPC. We're following the best security practices that we can. Now, let's imagine the CTO of this company has attended the BeSA program and heard us talking about all these amazing serverless concepts. And the CTO's now thinking, let's make everything serverless. We're going to move all our applications to be serverless applications. So we do that. We're developers, we work for this company, and we love serverless as well. So off we go and we re-implement this application to be running on AWS Lambda instead of in EC2. We get rid of our load balancer, that's now API gateway. We get rid of our EC2 instances, that's now Lambda functions. But our database is still running in RDS. Let's say it's a MySQL database running in RDS. Okay. Now, the thing with Lambda functions is that Lambda functions always run in an isolated AWS managed VPC that can be accessed only by the Lambda service. So your functions run within an account and a VPC owned by the Lambda service team. And from within this VPC, the functions have access to the internet. They can call AWS services or other APIs, but they can't communicate with our database in the VPC, right? Because there's no network connectivity. We're following security best practices with our database in RDS, so nothing can access that RDS database. Now we've got our application running here that can no longer talk to our database. Thankfully, this is something that AWS have thought about. So when you deploy a Lambda function, you can choose to configure a subnet and a security group for Lambda to use. And the way the networking works with Lambda is actually really important to understand if you're working with these resources that need to be deployed in a VPC. So when you configure a subnet and a security group for Lambda, the Lambda function itself still runs within the Lambda service account. The Lambda will always run within that Lambda account. What happens when you configure the subnet and the security group is an elastic network interface gets deployed into your AWS account using the subnet and the security group that you provided. That elastic network interface is connected to a hyperplane NAT gateway within the Lambda service account. Now, what that means is that all network traffic leaving your Lambda function will now route through that elastic network interface. You see that on the arrow there. So any traffic leaving Lambda will first go to the ENI, and then it will route from there. So now we have that connection into our network. Why this is important to understand how this works is because when you deploy that elastic network interface, that will use up an IP address in the range of IPs in the subnet that you configure. Now, that will use up one network interface per Lambda function. So if your Lambda function scales and you end up with 1,000 execution environments, that will slowly use one elastic network interface. So that's one interface for one Lambda function. But if you're not careful with this, you can then actually exhaust the number of IP addresses available in your subnet, and then you can't actually deploy any more Lambda functions. So that's something to be really careful of if you're doing this kind of work. I'd actually always recommend creating a subnet in your VPC that is there purely for Lambda functions to route through. And that way you can control the number of IP addresses that are available for your Lambda function, and you lower that risk of exhausting things. So awesome. We can now query our database running on RDS from within our Lambda function. Excellent. That's solved the problem. We're good to go, right? Well, let's imagine this application also needs to talk to S3. Now, S3 is what we'd consider a public AWS service. And what I mean by public AWS service is that it sits outside of a VPC. The S3 APIs are called over the public internet. But because all our traffic leaving our Lambda function is now going through this network interface, now we can't query S3 because there's no route for our Lambda function to actually get to the S3 API. Now, I've encountered this problem many times. I've once spent longer than I'd like to admit trying to debug a Lambda function that wouldn't work, and it wouldn't work because I was calling, I think it was the Twitter API at the time for the thing I was building, but I had it inside of VPC, and I spent hours trying to work it out. Eventually, I realized that I just hadn't created a route to the internet. So what can we do with this? How can we make this work? Well, there's a couple of options, and someone has quite rightly called that out in the chat for VPC endpoints. So there's two ways we can give Lambda routes to things like S3. So if you need to connect your application to a non-AWS endpoint, let's say it was the Twitter API in the example I've just given, well, then what you need to do is you need to ensure that the subnet you deploy the ENI into has a route to the internet. And that's probably using a combination of a NAT gateway and an internet gateway to then give that route out from within your VPC out to the public internet. And that way we can get out to the S3 API. But yes, as a couple of people have said in the chat now, we can also use VPC endpoints for this. So if you only need to connect to other AWS services and not the public internet, then you can use VPC endpoints. And what VPC endpoints do is you can deploy a VPC endpoint for a given AWS service. So you might deploy an endpoint for S3, an endpoint for Dynamo, an endpoint for SNS, I don't know. And then all of the traffic will route through that endpoint to the AWS service. The other benefit of doing this is that all of your network traffic will then stay on the AWS network. So if there's any kind of security concerns or any data that you're moving that you want to stay within AWS, you can then route that through a gateway endpoint, and you can guarantee then that all of your network traffic will stay on the AWS backbone. So there's a couple of options you've got there in terms of if you need to route traffic from your Lambda function to either public APIs or other AWS services. And there's another benefit to doing this for the security conscious amongst us, sticking with Ashishi's theme on encryption today, that this gives us the opportunity to maybe deploy some kind of firewall in our VPC. So that way we can then inspect or control all of the traffic coming out of our application, because we can guarantee that any traffic coming out of Lambda will then route through our network. We may have a firewall in that network. So you can use this if you have any security conscious workloads. When it comes to configuring this, you can configure this connection either in the console. So if you go into the Lambda console and go to the configuration tab, there's a VPC section. And in there, you can select the VPC and the subnets and the security groups. You can also configure this in infrastructure as code. There's an example there in CloudFormation. If you're doing this in CloudFormation, you don't actually need to specify the VPC. You just specify the security group and the subnets, and CloudFormation infers what the VPC is from there. Okay, happy days. Now we've got everything we need, right? We've got Lambda functions. We've got communication to our database. We can get out to S3 and we can talk to S3. Now, can anybody see another potential problem we've got with this? And just drop a message in the chat if there's anything else you can see here that you think might cause a problem as this system grows. It's perfect. This architecture is perfect. Awesome. So let's think about Lambda and the way Lambda scales. So if we think back to the first session we had on Lambda, each Lambda function runs in a completely independent micro virtual machine, its own independent execution environment. Yes, absolutely right, Puant, scalability. So what this means is that every single execution environment will create its own independent connection to the database. So if we receive a sudden unexpected load into this architecture, let's say suddenly we're starting to get hundreds, thousands of requests per second, Lambda will scale. API Gateway will handle that. Lambda will handle that. So then we start to get more and more Lambda execution environments, more and more connections to our database. We've now got 4 separate connections to our MySQL database. But Lambda will keep scaling, right? That's one of the benefits of Lambda, is that it will just scale to deal with your workload. As a default, Lambda allows up to 1,000 concurrent execution environments. Now, that would be 1,000 separate connections to our database. This can cause a lot of problems with most relational databases, because most databases aren't just set up to deal with that number of concurrent connections. And of course, another couple of people have already called this out in the chat, and I was going to ask, what can we do to prevent this? How can we prevent this issue? And as 3 or 4 people have said now, of course, RDS proxy is the answer to this question. So RDS proxy supports Aurora with MySQL, Aurora with Postgres, RDS for MariaDB, MySQL, Postgres, and Microsoft SQL Server. And what RDS proxy does is it maintains a pool of connections to the underlying databases. So the connections to the actual database itself are from the proxy, not from our Lambda functions. So yes, I'm just looking at the comment at the chat. We could use read replicas. You could end up in the same situation with your read replicas though, because you could just take your read replica offline because of that increased load. So yes, it's a very good point. You could use read replicas. You may still end up in the same problem. So now with RDS proxy in the middle here, all of our concurrent Lambda functions are communicating with the proxy, and the connections are pooled in the proxy, and then that load onto the actual database instance itself is less intense. But RDS proxy has a couple of other benefits as well as providing this serverless benefit. So if you have failover configured on your RDS instance, so let's say your RDS instance fails and you need to fail over to another instance, having RDS proxy can decrease that failover time by up to 66%, because RDS proxy can just switch the connection that it's looking at instead of needing to wait for RDS to fail over and then for the DNS name to change. So it can decrease your failover time in the event of an outage. Again, coming back to security, we love talking about security at AWS. The other benefit of using RDS proxy is that you can authenticate to RDS proxy with IAM, with an IAM role and an IAM policy. Now, what that means is that your application running on Lambda doesn't need to know about, understand, store any database credentials. So your application running on Lambda can authenticate to RDS proxy with IAM, with an IAM role and an IAM policy. And then the actual credentials for the database, the actual username and password for the database, well, that is handled between RDS proxy and RDS. And that means our application doesn't now need to worry about storing and holding credentials. So that is another great benefit of using RDS proxy, as well as dealing with Lambda scaling. So when we talk about moving to serverless, is an incremental process, right? If you have this situation where you've migrated some workloads onto AWS and you want to start using serverless technologies, attempting to do that in one big bang and just serverless all the things, as exciting as that would be to do, is probably not the best approach. You want to try and be incremental about it. So let's again walk through another example. So let's say we've picked up our application that was running into, yes, SQS is actually a really good example of something else you could do there. So you could have your Lambda function talking to SQS, and then you could have the actual writes to the database coming through from SQS into the database to kind of flatten that load a little bit. So yes, that would work. The challenge you'd have there is that you would have to deal with the eventual consistency, because let's say that the data comes in from an API call, you write to SQS, it may be 10, 20, 30 seconds till that data actually reaches the database. So SQS could be used for writes. That still wouldn't solve if you had lots of reads. If you had lots of GET requests to your API, SQS wouldn't help you with the read from your database. But yeah, SQS is a great shout to put in there as well. I mean, that applies, the whole VPC situation applies outside of just databases. If you're using something like Elasticache, let's say you've got Redis and Elasticache, Redis can only run within a VPC, so you would still need to consider these similar things to access Redis or any other services that run within a VPC. But anyway, let's say we've moved this application into AWS, and we've got these two applications that need to communicate with each other. And currently they communicate over some kind of API. But let's say you're working on the system and you caught my BeSA session a few weeks ago where we were talking about application integration patterns. So you thought, I know what I'm going to do. I'm going to put a queue in the middle of these two services, because that will make things more asynchronous and make things more scalable. But you're used to servers because everything's on servers. So you just spin up an EC2 instance and you put RabbitMQ on that EC2 instance. RabbitMQ, if you're not aware, is an open source solution for publish, subscribe, queuing workloads. So you can run that on EC2. So let's say you've done that now and you're like, hey, we've got application integration patterns. This is lots better. But actually what you've done there is just introduced more operational overhead, and you've introduced another point of failure into your system. Now you've got 3 servers instead of 2, and you need to operate these servers. This is, of course, considering you don't have any auto scaling in place either. So now we've got these at least 3 application servers that need to be operated. Let's say we get a sudden load into this system unexpectedly. Is our queue going to cope with that? If we're running this on EC2, that would entirely depend on how well and how quickly we can scale a RabbitMQ cluster, which is not an easy thing to do, believe me. So what can we do instead? Well, this is where we can start to have serverless and server-based workloads working together. Because instead of using RabbitMQ, we could have used SQS. And now we've got our application running on servers, but we're using a serverless queuing service. And SQS supports incredibly high load. For example, on Prime Day this year, SQS was processing 70.9 million messages per second at its peak. That's insane. It's crazy numbers. And SQS just scaled and just dealt with that. So now we've got our migrated application just running on servers like we're used to, but we've started to introduce some serverless components into our workloads. This will help us scale. It'll make us more resilient. We've got one less thing to operate and worry about. This can apply to databases, things like DynamoDB, Aurora Serverless. It can apply to our messaging solutions with like SQS and SNS, and even our analytics. For example, you could replace your analytics with something running on S3 with Athena. Maybe you can start to introduce these little pieces of serverless throughout your architecture without needing to rewrite your entire application. Because of course, there's also uses where serverless might not even be a good option. I was talking to someone this week actually who were developing applications against the Unreal Engine for building games. Now, for that, they needed a really specific GPU-based EC2 instance. Well, then that specific part of the application would need to run on EC2, but that doesn't mean other parts of the application couldn't run on Lambda. This gaming service may have the actual game running on EC2, but the customer account section on the website, that could be Lambda. So it's really important to not just consider serverless or not serverless. In the same way, serverless or containers shouldn't be considered as one or the other. All of these different components are different tools you have in your tool belt when you're architecting applications to build things that meet the requirements of the customer. Talk to the people you're building the application for and find out what the requirements are. Maybe you need to run some machine learning workloads or some high performance computing. Again, in them instances, you might need EC2 instances, but it doesn't mean that it needs to be one or the other. These things can work together. If I had my way, of course, I would move application B onto Lambda, but maybe you do choose to modernize some of these applications in the future. But having this incremental approach to these modernizations puts you in control of moving your services when you are ready. And starting to sprinkle these little bits of serverless around your application can help you start to modernize slowly and modernize in a way that you control. The point I'm using Apache Kafka as well as RabbitMQ, if you were running Apache Kafka on EC2 instances, you may well hit the same problem because you would still need to scale that Kafka cluster on the EC2 instances. So anything that's running on some kind of serverful workload, you need to operate and work with the underlying servers. So just to close out, what takeaways do we have from this session? Well, if you are starting to introduce Lambda alongside VPC-based workloads or server-based workloads, you need to consider the network connectivity. You need to think about what networking requirements your application has to make sure that you meet both the application requirements, but maybe to talk to external APIs or other AWS services. And probably the most important thing, and I've fallen foul of this in the past, I've forgotten this and overloaded databases before, but can your server-based infrastructure cope with how quickly serverless can auto-scale? Like I said, Lambda can, by default, will just scale up to 1,000 concurrent execution environments. That can be raised. That's a soft limit. That can go higher and higher and higher. So can your server-based infrastructure cope with serverless? And that's where things like SQS, as someone quite rightly pointed out in the chat, that's where SQS can become quite a really valuable service, because you can use SQS to buffer maybe some of the other parts of your infrastructure that aren't quite ready for that high scale. And finally, it doesn't need to be all or nothing. I spend an awful lot of time talking about serverless, and I love serverless, but it doesn't need to be one or the other. There are absolutely still scenarios where a server-based or a container-based workload may be a better fit. So always remember to understand the business requirements, understand what the requirements of the system are that you are building, and use that to pick the right solution that will meet the needs of your system. As always, any questions, drop them in the chat. I'll answer them now, or feel free to reach out on LinkedIn. Someone did ask in the chat for my LinkedIn, and I put completely the wrong link in there, so I will drop that in there now. But feel free to reach out with any questions. And yeah, now it's time for our special guest for this week. Let me just kill my screen share. There we are. Just give me one.
Thank you, James, for that. Sometimes we get so busy into just thinking about servers, but yeah, there is always integration required, and that given a lot of insight on how integration would be required and what kind of things would be there. Thanks for that. All right, everyone. Thank you for asking question, and James will get back to you and buzz him on LinkedIn. He would be happy to answer any follow-up question. And now we have a guest with us. So everyone, let me introduce Aisha to all of you. Aisha is a solution architect in AWS, and she would be our guest speaker today. And we will learn a little bit about her journey, what she's doing. She's passionate about having women into tech, so she runs a lot of non-profit work, and she would help us today to understand it. So please welcome Aisha. Aisha is based in Canada, and thank you for taking out time, Aisha, on a Saturday morning to help us with the session. Thank you so much.
No worries. I'm glad to be here. Hi, everyone.
Nice. And so, Aisha, what we have here, like we have people who are interested in knowing about solution architecting. Plus, we have a lot of girls candidates who are interested into becoming a tech person. So, help us in understand how your journey has been, and then we can take it from there. How you ended up into tech.
Okay. I'd say it started I think tech found me. I wouldn't say like I always wanted to be in tech. I actually when I was in high school, like I was a mathematics person, further mathematics, like I was so like I loved math so much that I wanted to go to university and study maths and statistics, right? But then like something happened and the course wasn't available anymore, and IT was like the next thing that was being offered. And then I had like a lesson teacher then who was like, well, computers are like, and this was a long time ago, obviously. Like, well, computers are like become the next big thing. I mean, I know you love maths, but maybe try something else, right? And even then, like my knowledge of, so I grew up in Nigeria. My knowledge of computers, I didn't really have a computer at home. Like we had one computer in school, or like no two or three in the computer lab, and you were only allowed to go during break time. And during break time, there was this long line of people wanting to play Mortal Kombat, and we didn't always have like we're just not able to like by the time you got to your turn, break was over, you had to go back to class. So I didn't really have a lot of access. But I then got into university, studied IT. It was difficult for me because I think like from it felt like if you didn't know programming, you were not going to be successful. And I wasn't good at programming. That like then they were teaching us like Fortran, some C sharp, and some Java, and for me, like, I don't think like my brain wasn't comprehending. So like I just figured like, well, if you're not good at programming, then maybe you're not good enough to be in tech. So I basically moved on after graduation and I tried a lot of things. So I started a business, a makeup and hair business. I was, doing a couple of different things but none of it was giving me fulfillment, right? Like I was like, okay, I want to get rich and this is not working out. And so I ended up like then there was a boot camp. There was like this um young graduates like introduction to programming, and I was like, maybe I'll eventually understand programming. Maybe it was the way I was taught, right? And then I eventually went for that to that boot camp, and it was just like a sort of like front end type, HTML type, JavaScript type. I was like, okay, it's not so bad. It's not as complicated as I like that I experienced when I was in university. And that was when I said, like, you know what, I'm going to go back. So I like in my mind, I was like, everything I learned, I don't think I knew enough. So I was like, I was going to go back to school, and then I went back to school. Did a master's in IT, and that was when I met the Django Girls Foundation. They had like a workshop, and then it was focused on like Python and Django. And then I basically became part of that community. Started up like a Python user group in Nigeria back home, and then it was like the first Python community as well. Started we organized like the first Python conference, and then I started a career in. I wanted to be a data scientist, right? So I got my first job then as a data engineer. And but for some reason, Cisco came knocking on my door, and I'm like, "What? Like, I'm gonna do networking? Like, ew! Like, like I want to do data. Like, data is the new oil. Like, that's the fun. Like, you just want me to be doing switches and routers. I'm like, nah, you're kidding me." So I was like, "Well, but it's a big company, and then they were offering like all these like graduate training programs where in the first year you're in a hub, and so they were going to take us, like for me, it was Czech Republic and our hub was Amsterdam. And so we're going to go there for 1 year, like, be deep in tech. And it was an opportunity that I was like I was like, you know what, I was going to take it and see how it goes. And if I don't like it, I'll just go back to my data, like, my passion or whatever. And then I got hired as an associate systems engineer at Cisco, did the graduate training program, which was a mix of like classroom based learning
Mhm.
and field training. We have something very similar at AWS as well called TechU. But then I ended up, going through that process, worked at Cisco for about 3 years. And then I moved from Nigeria to Canada and I got my job. And then, so at Cisco, I was a data center SC because I was like, okay, I mean, maybe I cannot go into data science, but like instead of being in the org person, I'll be close to the data set, at least closer to where the data is, right? So I ended up,
Yeah, that's
um,
interesting.
yeah, I know, like, and then eventually, when you work in a data center in a company like Cisco, everybody's talking about the cloud, like in one way, shape, or
Hmm.
form. I had customers wanting to know about the cloud, and I was like, you know what, maybe I need to learn about the cloud so that I can help my customer make the decision that they need to stay on premises, because then I was looking at Cisco, or do like a hybrid
That's
cloud or whatever hybrid
great. That's
situation.
great. Now,
Yeah.
if you look at the journey, like what was the most significant turn of the event or the point where your career take a completely different turn, or what you are today? What was the significant event in your life which shaped you today?
I think it was the boot camp for sure that I attended. It was the boot camp first that helped open my mind, that helped me
Okay.
start to think differently. And then when I got into the Python community, Django Girls, and the Python Software Foundation, I was like, oh my gosh. Then I acquired like mentors and coaches, and I had this. It wasn't just me anymore. I had the support system in the open source community that really helped me. So that I would say was the real turning point for me.
With the boot camp, actually, like, how did you go about finding the boot camp? Like, was it just like Google searches, or was it someone that you knew who recommended it? I just think that'd be quite interesting for the people listening to find out how.
I was job hunting. Like I was at that point. I didn't even decide I was gonna. I was just like applying to everything. Like I was like, okay, looks. I was, when you come out of uni, you just need your first, you just need the first leg, and then I was applying to everything. Obviously, I wasn't getting successful, and then all of a sudden, oh, send my voice is echoing. Is that true?
Sounds like it is. So there's a little bit of an echo, but I can hear you. Okay, it's absolutely fine.
Yeah,
Oh,
that's
okay.
okay.
All right. Um,
Good.
I'm sorry. What was the question?
No worries. Yeah, there is a question that, hey, what kind of boot camp it was? Like, can you shed some light on that?
It was back home. It was like
Okay.
a 3 weeks boot camp. But like one I would really recommend that I eventually did was Java Girls Workshop. They're like in-person workshops. Well, maybe specifically for like women, who want to get into like tech or programming. Um, yeah.
Good, nice. And when you look at your job currently as a solution architect, what do you think are the most challenging things you do at your work?
Hmm. I would say, for me, the most challenging part is the amount of information I need to know and absorb
Exactly.
on a daily basis, and it changes. Oh my gosh. So I support like customers who are new to the cloud or just new to AWS in general. And I find that every day I have very different conversations. Like I could speak to three customers in a day, and one call is end user computing, a different call I'm talking about AI, the third call, no, we're talking about disaster recovery. So the level, the breadth of knowledge that you need, I mean, and it comes with time. It's not something that you would get on day one, but like it's. I think for me, that's the most challenging part: being abreast with all of the information, so that when you go to the customer, you're not giving them outdated information. And trust me, many times it's outdated because between 6 hours ago and now, like many things have changed.
Nick, this is interesting. Yeah, I agree on that. Now, our audience are quite chatty here and they are happy about your journey. And they want to know, like, how did you become solution architect at AWS? What skills has been picked up by you, or what helped you becoming a solution architect? Was it a certification? Was it a referral? Was it something you were doing on your own? How that clicked?
So to continue my story, I moved to Canada. I was in SC at Cisco in Nigeria, and then I moved to Canada, and then I got my first job as an Azure SC, and that was because I was doing I did like an AWS certification, cloud practitioner, and solutions architect. Remember, I said I wanted to learn so that I can help my customers make the decision to hybrid cloud or just stay on prem. But I found that coming to AWS, what really helped me was I did not just have some experience with cloud, I knew how things were done fundamentally on premises. And that's the foundation that you literally need in terms of like, it's not just the cloud. The cloud at the end of the day is somebody else's data center that you're connecting to, right?
Exactly.
So you need those fundamental networking concepts, operating system concepts. Like if you're doing certification in AWS, it's great, but you have to go back and learn the core fundamentals to be successful in this role, because the customers you'll be talking to, the customers you'll be helping architect their solutions, many times have an on-premises footprint, and many times they will use their on-premises investments and vendors on the cloud as well.
That's it. That's good. Right. And how you like keep yourself updated? As you said rightly that there's too much information, right? So
Mhm.
how you keep focused on learning specific things or specific technologies or upskilling on new things? Because that's a challenge with everyone today. There's so much to learn and we have so little time. So how we could channelize our efforts in a way that gives the most return on what we are doing?
I would say you want to make it relevant, right? So for me, I don't just learn a concept if I don't have an immediate use case or need, because it's one thing to read about a topic, it's another thing if you don't have a practical use case or example that you're applying it to. So for example, what influences what I need to learn is like my customers and what they need to know. If it's all about Kubernetes and they really need to modernize, and they decided they want to do Kubernetes, then I that moment in time, I'm focused on learning Kubernetes. I'm also part of a something called the technical field community, and I focus on end user computing technologies. That also helps me focus what I need to study or what I need to learn. Certifications are amazing; they're great. If like me, your memory is not so great. I probably like it's a ton of information. As I absorb more, then some other information go out. Like I need to go back and and reread. Then you just find out that you need to. For me, I need a use case. I need a practical example of why I need to learn this so that I can apply or help my customer. and it helps it stick for me because it's not just about technology; it's about the problem the technology is solving.
That's interesting thing. Yeah. Yeah, that's like solution architect are like considered like a master of everything, not master of none. But yeah,
Yeah.
they are considered master of everything because they have to know everything. Maybe you are working with one customer and that customer may have 10 teams and 10 questions. So you are always on the top of your toes trying to look for new information. And sometimes it happens like sometimes customer are a little more aware and then it challenges you much further. So yeah, interesting thing. Good. Now, I want to hear about your migration journey, like not from the technical perspective, but you migrated from Nigeria to different places and now you ended up in Canada. How you adjusted to that? Because it's not an easy thing, isn't it?
No, like my entire family is still back home. Just me and my husband live in Canada. So, and I miss my siblings. I have like five siblings, and I miss them. And my parents, they're still back home. It wasn't easy for me, but I knew that I needed to grow. I needed a change. I needed a more enabling environment. And I don't think I'll be the person I am now, the knowledge, or even be at AWS if I did not move from Nigeria. So it was difficult. Like it was, I like to say, it's the bravest thing I've done, and I probably will ever do. But I just had bigger dreams that I knew that I wasn't going to be able to achieve them if I stayed back home. It was just a personal thing. It wasn't. It's no fault of Nigeria. I don't know if that answers your question.
Great, that's good.
Oh yeah. I think that somebody asked about like how I got into AWS. So like you asked like so I was working at a company as an Azure SC, and then the recruiter actually reached out to me on LinkedIn. I wasn't actively looking, actively applying, but they reached out to me on LinkedIn, saw my profile. I mean, you always want to have a very good profile, highlight all your certifications, the things you're working on. And then I went through the interview process, the phone loop, the on-site loop, um, and then yeah.
That's good.
Just to
Uh,
follow up on that, because there was one more question just in the chat. I'm just conscious of time as well, Aisha. But someone's asked, how did you prepare for the interviews? So when you were going through the process, like what kind of prep did you do for the AWS interviews?
To be honest, I went back to so I'd done the exams like AWS exam like a long time ago. So for the interview, I literally went back to A Cloud Blue and went back to refresh my memory. I had to only because any company you want to join, whether it's AWS or any other company, you want to understand what their core values are. At AWS, we call them leadership principles, and you want to make sure that you're aligning your experience, the things you've done with that company's core values or mission or leadership principles. So for me, I actually went back. So there's a very technical aspect, but a big aspect is also the behavioral aspect as well, right? So being able to articulate how your previous experience puts you in a position where you would fit into the company based on their values, right? At the end of the day, you're interviewing a company. Sorry, a company is interviewing you. You're also interviewing the company to see if they actually align with your core values. Like, do they believe in the same things that you believe in, right? And so for me, like I had to align my experiences with the leadership principles of AWS because they were. We always say this joke that there's a lot of Amazonians out there. We just need to find them. Like, not all Amazonians are at Amazon. And then for the technical part, like I just had to refresh my knowledge, remember, and I used A Cloud Guru to do that. And then my current experience, I was working with Azure a lot. So the good thing is they don't require that you have, and that's the thing I wish someone told me. They don't really require you to know AWS. If you know a different cloud or you know a different like vendor, like maybe on premises or even open source technologies, I can assure you that the people that interview you actually have worked in multiple different places and have like a very broad knowledge of like what's out there. So it's okay not to know AWS specifically.
Yeah,
that's
that's also not
interesting.
nice.
Yeah, that's good. Now, I see you do a lot of work on talk about inclusivity. So how AWS helps you, or what is your meaning of inclusivity? Because when we come from different background and work in a team, then things sometimes work well, sometimes it doesn't. So how you look at inclusivity, and what would be your advice in those kind of situations?
For me, inclusivity is everybody feels welcome, everybody has a voice, and everybody's voice is heard, regardless of their background, their abilities, regardless of what they look like, regardless of where they come from, regardless of how they speak, right? Because like accents too, like could be like, oh, where do you come from, right? So for me, like at AWS, like we have a lot of like groups that sort of like cater to different just different aspects. Like we have the Black Employee Network, we have the Mental Health and Wellbeing Network, we have the Family, the Amazon Network, we have a ton. We have body inclusivity. We have a ton, and there's a space for everybody. And like for me at AWS, like I'm very lucky. Like I'm technically the only Black person in my team, but I'm very lucky to work with people like amazing people who just want to see you grow regardless. Like we have this joke that we don't hire hassles. Everybody's so awesome and great, like super smart people who want to see you grow. And I think,
Exactly.
and that's the reason why I've grown so much. Like everybody, we talk about the high bar, the bar. For me, the bar is October 29th of 2021. Am I still the same Aisha, or have I grown from that Aisha I used to be? So the bar is my previous self for me, not just the general bar. The bar is, am I growing? Am I developing?
Yeah, that's excellent. Now, when somebody asks me question about, hey, how is working for AWS, I always say that I am yet to meet a average person in AWS. I haven't met any average person so far. Everyone I met with is so excellent, so top notch. Means you sometimes feel dwarfed on a bench, or like you feel like, hey, we are into a room full of so talented people, and you feel little insecure initially, right? But yeah, that's the thing about AWS, that they keep you inclusive, they support you, so that's a good thing. Now we are nearing to the time frame, Aisha. Now I want to ask you, like, if you have two advice to give to any of the aspirant for solution architect, what would be top two things you would give as advice to somebody who is starting the career or try to become a solution architect? Two advice.
I would say like you just have to keep learning. And it's you could the more I've realized that the more I know, the more I realize I don't know. Like you just realize
Exactly.
there's so much you don't know. And it's okay because you're not required to know everything. Just as long as you're learning and you know in yourself that you're improving, you're growing. It's little steps, it's little steps. You're not going to be the solutions architect in one day. And even when you get hired as a solutions architect, you're not going to be able to be everything in one day or know everything in one day. It's a process. So I would say like trust the journey. It's not really about the destination as it is about the journey. Trust the journey. Trust in yourself, your abilities. Realize that you are the bar. And if you're better than 2 months ago when you picked up an cloud guru course, or then you are improving. You're doing great. So I would say learn as much as you can. That would be, and trust the journey. And everything falls in place. Like everything falls in place eventually. But just trust in your abilities. Like I don't want to be like, oh, you can be anything you want to be, but we really can be and do anything that we want to
Exactly.
do that we put our mind to.
That's good advice, Aisha, and I'm sure people would be benefiting from it. And thank you so much for taking out time. I'll wait if anyone has any last minute question for Aisha, and otherwise we will wrap it up. And it was so interesting to see you, and thank for making out time on Saturdays. And obviously, it's very important that we bring people from diverse background, because everyone's journey is different, everyone way of thinking, everyone's approach is different, and obviously there is always anything to learn from everyone. So thank you so much, and we hope to see you in some other sessions, and probably you would have more LinkedIn followers now. So thank you for being here, and we hope to see you in some more event. Thank you.
Of
Have a
course.
good one. Take
Thank
care.
you
Thank
everyone for having me.
Thank
Have a
you.
good
Take
weekend.
care.
you.
Bye.
Bye.
So thanks everyone. Thanks for spending time with us. And Aisha was kind enough to spend her time with us. Hopefully everyone has learned something and have some more inspiration. So have a good weekend. Keep learning, as she said, and that's what I always say. So we hope to see you in the next session, and we will have more discussions. Keep coming with your feedback, any suggestions, anything which we could do differently to make your learning better. We would be happy to do that for you. We are all here to help you. Sometimes we have limited bandwidth, but yes, our intentions are still the same. We want to help as many people as we can. So thank you so much, and we see you next day, next time. Have a good one. Thank you,
Thanks,
everyone.
everyone.
Thanks,
See you next
James.
week.
Thank you. Bye.